So, hello everyone. Good evening. Good evening to everyone. Hope you can hear me. Please, can you all send a comment on the chat if you can hear me? Good evening, everyone. So, today is the third day of the data visualization using Python session. And good evening, everyone. Good evening, Shilpa, Sushil, Sachin, Riddhi, everybody. So, can you hear me? Can you hear me now? Yes, am I audible? Good evening. Hi. Yes, audible. All right. Can you see my screen? I have shared good evening. Good evening. Yes. Is my voice low? Just a minute. Let me check it. Hello. Yeah. Can you hear me now? Am I loud and clear? Yes. All right. So, uh, I hope you already have you already got an insight about what data visualization is all about, based on what we saw in matplotlib. An introduction we saw, we saw different types of plot. On day one we saw about line plots or line chart, and line charts are basically nothing but plotting any series of data points as a with respect to time, okay, on a time series data frame. And anything which varies with time, okay, if you're given a data you can use a line plot. Yesterday, on day 2, we started with bar chart. What kind of an interpretation can you draw using a bar chart? And we saw about histograms. What is unique about histogram, and why do you plot a histogram? What does it show? The density within a range, or the frequency, is what is shown using a histogram. So yesterday on day 2 we saw bar chart, histogram, we even saw a scatter plot, and we saw about a pie chart. Okay, and all these visualizations that we did, we used a library called matplotlib. We installed it on day 1. I used a Jupyter notebook, and yesterday we saw all the visualizations done on a Google Colab. Okay. So today, on day 3, we are going to start with another library called Seaborn library. Okay, we are starting with Seaborn, and we'll see. Okay, this is nothing but Seaborn is a library which we use for any kind of a statistical analysis. Okay, so any kind of and it is built over, okay, it is a edge, it's it is one edge over matplotlib. Okay, matplotlib is the most basic library, okay, for done for which we use for data visualization. And Seaborn is a step higher. Okay, it has a higher edge over the features that it brings about, the way it captures the entire data frame, and how the plotting is extremely simple and it's very unique. Okay, you can just load in the entire data set and you can start plotting. Okay, you can draw relation. So it is a little higher level compared to matplotlib. Okay, so today we'll start with visualizing the statistical relationships between variables. All right, so students, all of you can open your Jupyter notebook, or you can open your Colab, anything. Okay, one of the two. uh, uh, so can we start today's session? Please say yes if you can, if you can start. I'll zoom out a little bit so that you can see. Okay. So today's session is all about how do you plot, okay, numerical data using different kinds of plots using SNS, okay, Seaborn library. So I hope you can. So today, let's C. Okay, so Seaborn library is mainly used for, as I told you, it's used for statistical analysis. All right. And there are so many things that we can do. So the first thing that I would like you to do before we start is just understanding what do you mean by statistical analysis. Okay, it is just that you have to understand how the different variables are related to each other, whether they are positively correlated or negatively correlated. So statistically, how are the relationships between all the variables? So that's what we will analyze using these kinds of visualization plots. Okay, and so obviously when you have a plot between two variables, two numerical variables, and you plot the relation, okay, it gives you it gives you a very clear trend of how the variation, how the relationship is between two different variables, howsoever complex it may be. All right. So in Seaborn library, okay, you can the first thing that you can, so these are the different types of way in which we can draw a trend or pattern. The first one is numerical data plotting. Okay, so all the numerical variables can be plotted using these plots. The first one is rel plot. Okay, it's a relational plot. The second one is a scatter plot. Okay, and the third one is a uh, line plot. All right, so these are for numerical data. For categorical data, again, you have many different types of plotting. That is categorical plot, that is cat plot, box plot, okay, strip plot, violin plot, swarm plot, etc. And for visualizing the distribution of data, okay, how it is
Excuse me,
distributed.
ma'am.
Yes, yes. Yeah,
Ma'am, can you please zoom it a bit more?
I have already zoomed it, but okay, let me, okay, how about this?
Yes, yes, that's fine.
Okay,
Thank you.
so yes, yes, okay. Ma'am, can you zoom? Yeah, can you zoom more? Okay, okay. So I hope it's visible. All right. So as I told you, so the first thing that we'll see is numerical data plotting, and then categorical data plotting, and then how the distribution is. Okay. Uh, what type of, whether it's normally distributed. Okay. So, and then we'll also draw a regression plot. Okay, to show the reg plot. Okay, LM plot and all that, to show the regression plot. And then these are the different other aesthetics that you can add, how you can add more aesthetics, in the sense, how the look of the graph or the plot can be made better. Okay, so let's start by importing the necessary libraries. Okay, so I would like all of you to do this with me. The first one, okay, as usual, numpy, pandas, these are the dependencies that come along. You have to import matplotlib. From matplotlib you can import pyplot as plt. Okay, and also mention matplotlib inline. Okay, so these are the libraries that we would be using for data visualization. Okay, okay. So you can all do it. Have, if you have imported it, you can just okay, and then we can load the first data set. All right, so you can give this first data set. Okay, tips is equal to sns dot load underscore data set. Okay, so in sns, this is a function, okay, called load underscore data set. What it will do is it will load the entire data set. In matplotlib, how we were doing in matplotlib, if you remember, we were doing using pandas. Okay, it was pandas that was used to read the file or load the file and read it. Okay, but here in sns you directly have a function called load underscore data set, and this is the first example that we'll be looking at. All right, tips is a uh, data set which is already present, so you can load it. So if you have you loaded, have you all loaded the data set, this sns dot load underscore data set? Okay, have you all loaded? Yeah, sure, sure. Abhishek, okay, you can all do this. Okay, till here. Import all the libraries like Cbon, NumPy, Pandas, Matplotlib, okay, and then load this data set. We'll first load the data set and just, okay, let's analyze this. What this data set is all about. Please show importing. So these are the libraries that we imported. Okay, see, import Cbon as SNS, import Pandas as PD, NumPy as NP, matplotlib.py, plot as PLT. All right. And let's analyze this tips data set. This is nothing but it's just a relationship. It's that's a data set that shows the total bill. Okay, in some restaurant. Okay, this is the total bill amount. This is the tips that, okay, the additional tip that, the amount of tip that the person has paid, the sex of the person, okay, male or female, whether he is a smoker or no, and the day, whether it's Sunday, Monday, okay, and what time, and the number of people. Okay, so this is just a statistics on tips. So how much tips? So obviously the tip amount depends a lot on the total bill. Okay, so you can analyze, and these two are numerical variables, if you can see. Okay, it's numbers, it's all numbers. The total bill amount is numbers. The tip is also a numerical column. It's a numerical feature. But whereas if you say, if you take this column, that is sex, we are just trying to understand the data set. Okay, we are just trying to understand the data set. So the minute you load a data set, you can just take a look at the data set and see. Okay, so sex is nothing but it is called a categorical feature. Okay, because if you type, there are only two values possible. Okay, two categories possible. It could either be a male or a female. Okay, so that is a category, it's a categorical variable. But whereas in tip column as well as in total bill column, if you see, it's a series of numbers. It's in the, okay, so it's a series of numbers which are actually of float data type. So these are numerical columns. Okay, smoker, again, see, smoker, day, as well as this time is also a categorical variable. Here the size also, it refers to, you can, you can either, this is nothing but, so two, it's repeating. See, it could also be called a categorical variable. All right, so you have, you can analyze. Let's analyze using SNS, using Cbon. Okay, so as I told you, okay, the first thing is we are just using a relational plot. Relational plot, the plot is nothing but rel plot. Okay, dot sns dot rel plot. Okay, this rel plot is used to, it's a relational plot which is used to relate two different numerical variables. Okay, so x is nothing but, we are defining x in the plot. X is the total bill and y is the tip, and the data is nothing but the way we have saved the, we have loaded the data set and we have saved it as tips. Okay, so this is the column, this is the name of the data frame. So you have to give the name of the data frame, and if you execute it, you can see a plot here. Okay, so this is the total bill amount as well as the tip amount. Okay, total bill versus, so what do you see here in this plot? What do you see in this plot? So as the total bill amount is increasing, mostly, okay, the tip amount is also increasing. So if you see, somebody has paid a tip of close to what, 10, okay, for a, uh, so a a tip of 10 has been paid for a bill amount corresponding to how much? Around 50. Okay. So that is how you relate it. Is that clear now? So, so did you all understand what is this rel plot? Have you all understood what is a rel plot? You can all type it in the chat now if you understood what this sns.rel plot means. Okay. Sorry about it. So have you all understood? Explain once. All right. So let me explain it again. Just a minute. Okay. See here, what we have done is we are just visualizing using Seaborn library. Okay, so you have imported these libraries, that is Seaborn, Pandas, NumPy, Matplotlib. Okay, and we have loaded a data set called tips data set. It's already pre-installed. Okay, these data, there are a list of data sets that are already there in Seaborn library, and so we are loading one of the data set using load underscore data set. Okay, and we are giving the name of it. Okay, and we are viewing the first five records. Okay, in order to view the first five observations, you can use the command tips.head. Okay, so, and if you want to see what is the total size of the, so you can use the word tips dot shape. Okay, so what does this mean? Tips dot shape is nothing but it will see you how many rows are there and how many columns are there. See, so you have a total of 1, 2, 3, 4, 5, total 7 columns, okay, and a total of 244 rows, okay, or records or observations. Okay, so this is the shape of it. Suppose you want to see what are the columns. Okay, so you can just type in columns if it's a huge data set. Okay, so it will give you the names of columns. If you want to see a particular I told you, category. Okay, these are called categorical variables. So you can just put the column name, okay, within square brackets. That is, for example, the day. Okay, I just say day, and I would use the word unique. Okay, so these would say me the possible days that are in the data set. These are the days wherein the records have been observed. So it's only Sunday, Saturday, Thursday, as well as Friday. Okay, so these are the ways that, see, these are the basic. So it's called an, whatever we are doing currently is called exploratory data analysis, EDA. So this is what is called, you are just exploring more on data, you're just trying to explore the data. Okay, so if you give tips dot, okay, info. Okay, this will give what is the data type of each column. So float is nothing but it's a decimal place. Okay, it's a number with decimal. So float, these are categorical variables, and again size is also a number, so it's an integer. Okay, so if you give describe, okay, you can try all this along with me. Okay, you can just try. Okay, now describe is nothing but it will just give you the for each particular column. Okay, like total. So describe, it only will include a numerical column. Okay, so if in case if it is stitched or described, you can view what is the. So these are nothing but the basic statistical values. Okay, what is the minimum value of the total bill, what is the maximum value of the total bill amount, what is the minimum tip value, oh sorry, what is the minimum tip that a person has given, what's the maximum tip, what's the standard deviation. Okay, what is the mean amount, average amount of total bill, and then count the total count. Okay, and these is the 25th percentile, 50th, 75th. Okay, this we'll see when we are doing the box plot. It just shows you the the spread of the data. All right, so these are the different exploratory data analysis that you can do on any data set. Okay, you can explore more on that. So any data set that you can do you can do EDA to learn to just know more about the data. Okay, so now the first thing that we did here is the rel plot, sns dot rel plot. Okay, so here you're just giving x label, x as total bill amount, and y as tip, and the name of the data frame, and you're getting this plot. Okay, so you just have to understand how the plot is. So as the total bill amount increases, the tip also increases in between. Okay, there are some variations also here. There are certain data points that are varying. Okay, let's move on to the next one. So this is okay, the smoker value counts. So how many, so what does this value count means? The number of, so as you saw in the column that is smoker, there was just a no and a yes. Okay, so if you you can you can see the amount of the different number of people. Okay, number of records wherein it's no or yes based on the value, number of count. Okay, you can even plot a bar chart on it and you can see it. Okay, now let's go on to the additional. Okay, so far what we did was only till here. We added x label. Okay, in x axis we added total bill column, in y we added the tip, and we added the data. Okay, now you can add extra groups. Okay, you can add an additional column that is called a hue. Okay, so on the basis of whether the person is a smoker or the person is not a smoker, we can add this particular value. Okay, whether the person was a smoker, yes or no, that can also be added as an attribute to the graph. Okay, to the same graph. So whatever we are seeing here is the same graph. Okay, whatever we saw earlier and here is the same. It's just that you have added an extra. So you, as you see the points of total bill varying with tip on x and y axis, you can you will, there is an additional, apart from identifying how it is varying. Okay, you'll get an additional information of for a particular point whether, okay, the person who whose bill amount was this, whether he was a smoker or no. So that's the third information that you're getting. The first information is what you're just basically plotting and relating it. Okay, and the second one is you're seeing how the correlation is, how tip and total bill amount is related. And the third thing is you're just adding an additional column, okay, to it, and you are visualizing it in terms of the color. Okay, difference. And next one is the style. Okay, whether it was the the third, whether it was lunchtime or dinner time. Okay, so you're just, so these are the additional, you're just signifying, you're adding extra information to your graph. So style equal to time. In your data set, if you saw, you had this extra column called time. Okay, so you can add that as well. So there are only two values in time, just lunch and dinner. Okay. So did you all understand? Have you all plotted this relational plot using SNS? Please get to your chat and give me a thumbs up if you have completed till here. Okay. Two things that you have plotted: relational plot using just XY. Okay. And you have loaded the data, and additionally using this hue and style. Okay, just give me a thumbs up if you have completed till here. Let's take a small pause and we'll continue. What is a data visualization? Data visualization is nothing but it's just a technique of, analyzing a raw data in terms of plots and graphs. I hope I am clear. Give me a thumbs up if you have completed till here. Thumbs up, everyone. Hue is nothing but an additional group. A couple of people, Tanisha, people are asking what's in hue. Okay, it's just a group or category that you're adding to your plot. Thumbs up. Plotted? Okay. Shall we move on? Very good. Very good. Excellent. Okay. Thumbs up. Yeah, yeah. Okay. Okay. So if you have any doubts, what you can do is you can go to your, okay, one second. Just go to Google, all right, and type SNS, okay, rel plot. Okay, just type. It's not, okay, you can you see my screen? Just type, okay, cbon.rel plot, and you can open this entire documentation of cbon. Okay, so apart from, so right now what we have added in using cbon is a library, and we have done using railplot. And what is a railplot? They have explained it here. See, it's an interface for drawing the relational plot on a facet grid. Okay, so it shows the relationship between two variables with semantic mappings of subsets. What do you mean by semantic mappings? These are nothing but some kind of, it should be similar. Okay, so you can go through this. So we have added an X, you have added Y, you have added a hue, you've added a data. So all these can be added. Okay, so you can go through it whenever you have time. You even have a tutorial over it. And okay, you can go through this documentation, and basically here they would have given, see, hue equal to day. See, they have even given an example about the kind of maps that can additionally be used apart from the, uh, you know the different types of plot. Okay, so, okay, so as I told you, it's the same data set, and you have, added only day. This is only using day. Okay, uh, so X is total label, Y is the tip amount. You can go through this. Okay, you can even add, and even you can separate it and add a time also. Okay, and yes, similarly you can add x equal to x equal to total bill, y is the tip, hue is the day. You can add an additional column called time. You can add an additional, column called, a row. Okay, column and row. And this is the same data set. Okay, so this is the same thing. You can just go through the documentation later on. Okay, and you can execute it and see for rel plot. Okay, similarly they have taken another, data set, that is fMRI. Okay, data set. Okay, you can go through it regarding, this particular documentation. So any doubts you have, you can just take a look at it. Okay, now let's move on. So suppose, okay, now here also we have used another one. It's the same thing. You can try this. Okay, this is also a relational plot showing the difference between an x and y, both the same data set, and you have increased a style as size. Okay, what is that? Style equal to size. Size is that last column that you saw. Okay, so different sizes that were available: 1, 2, 3, 4, 5, and 6. So there are or by default each of these values are assigned to a different type of a what shape. Okay, so you have this circle, cross, square, plus, everything, diamond. Okay, so you can just go through this. You can, this is the same plot. Okay, and then you can add, these extra, it's the same thing, hue equal to size. Okay, this one was style. Okay, the style of it. Okay, how the plot, in the plot the markers were the shape, the style of the markers were what was called style. If you replace style as hue, okay, it'll be different. So if I type hue here, okay, so that'll be different. Okay, these are nothing but the hues. Okay, so based on the color palette in the sense the color intensity varies. Okay, for one is the size. So that observation, size one, in the sense in that particular record the size was one, so only one person had gone to the had paid the tip, and it was corresponding to a total bill for a size of one for one person. Okay, so we'll move on to the next one. So okay, this is also, you have data as same thing. Hue is the smoker. Okay, style is the time. Okay, so if you can see the time, that is, lunch, so that is the style. Okay, the marker, the marker pattern is labeled as style, and hue is nothing but it defines the color. Based on the color variation, you can it has been labeled. Okay, and the size equal to size, that means the third part. Okay, the size of the marker. So each one, so if you see here, almost I think all the columns have been included in this. Okay, maximum information has been compressed, but there is nothing, there's, you have to just analyze it. So right from the beginning, okay, from the first plot that we saw, wherein it was only x and y plane plot, you added an extra thing. Okay, a third column called hue, and a fourth thing called style, and the fifth, so it was nothing but, you are just adding more and more in the same plot. You can see how much more information can be added. Okay, so that's the significance of this SNS plot. Okay, so those, so much of information you have not, unlike in matplotlib, okay, wherein you give plt.legend, you give a label to each of it. You don't have to do anything here. It's all, it by default, it is it's showing. Okay, everything is showing you there. We were, for everything we were labeling it. We were having the legends and labels for matplotlib, but here it's like by default the SNS plot is intelligent enough to give you a higher level plot. Okay, user interface plot. So have you all understood it? Next, we'll move on to the next one. Okay, so this is over. SNS.rel plot is all over. We'll move on to the next one. Okay, but before that, we'll again see. Okay, for another, we'll generate a set of random values. Okay, random numbers. Okay, and then we'll do a cum sum operation, cumulative sum operation, and we'll just view the data set. Okay, so you can import this particular, from numpy.random, you can import rand n. Okay, so all of you can execute this command. Okay, you can, this is nothing but you're just creating a data frame. Okay, with the value is nothing but random numbers, 500 numbers. Okay, and then you are giving a time also. Okay, you're creating a column called time. Okay, and then you're doing a cum sum operation. Cum sum is nothing but it is the cumulative sum. Okay, so let me show the code to you and you can do it all if you can try it now. So have you all done it? Line number 14 and 15, you can try doing it now. Yes, Rahul Shrestha, you are right regarding hue style. Okay, as well as the size, style, and hue. You are right. So I'm looking at your chat now. You can ping me any questions you have till here, and we'll move ahead. Okay. You can ask me any questions. I'm having a look at your chat. You can ask me any questions you have regarding this. Yes, okay, we'll move ahead. You all loaded the data frame and you can just view it, okay? So, yes, okay. Now just plot, okay? You have created two columns called time and value and you're just plotting the relational plot with this data frame. Okay, so you can see the plot as to how the values are varying with respect to the two columns, that is time versus value. Okay, so you can just plot it the same way. SNS.rel plot x equal to time, y equal to the second column name, any column name that you have given in the previous data frame, and the kind is equal to what type of plot you want. Okay, is it kind or okay? So you can just put it and okay, and this is the data frame, data equal to df, and sorting is done here. Sorting equal to true because it's sorting it in one order. Okay, so here if you see the values are not sorted, you can see here it's 0.18 minus zero point 0.7 and then again zero point 0.2, so it's not sorted. So you can give sort equal to true. Suppose if I give, let's see how the if I give sort equal to false, which is a by default, how the graph would look. It wouldn't, it would be fluctuating, so it wouldn't be clear. Okay, so let's give it as, let's sort the values and then plot it. Okay, okay, and let's move on with the second type of the plot here. Okay, you can try this. Okay, let me give this to you as an assignment. You can load this data set, okay, fMRI data set, and you can view how the time point. Okay, this is nothing but a functional MRI data set. Okay, regarding the data set, you can take a, again, see, SNS fMRI data set. Okay, you can just see, explore more on that data set. Okay, okay. So okay, regarding the fMRI data set, see here. Okay, where is it? It's um, SNS fMRI data, fMRI. Okay, description about the data. So it was nothing but it's see, it just measures the blood flow to assess the brain activity. So it's a functional MRI signal. Okay, it's an imaging record. Okay, wherein you have something called a time. Okay, time time plot and time point, the subjects, event. Okay, which region of the brain has been recorded, and the signal. Okay, fMRI signal value. So this is nothing but the subjects. So you can just take a look at it. Okay, you can load the data set, and before that you can just view how the regions are. Okay, you can just plot this and see. Okay, so SNS, uh, what is the name of the data set is fMRI. Okay, so fMRI dot info. Okay, what is the information? It's these are the variables. Okay, dot shape. So info will just give you the data shape, data set, the data type. These are the number of records that are available: 1600 and 1064 rows and just 5 columns. Okay, and then if you give dot describe, it will help you with the okay, how the signal and time. These are just the of all the columns. If you give describe, because it's only to a numerical column that you can find out the mean, average, standard deviation and all that. Okay, so it's only the two numerical columns that are displayed here. Okay, so you can understand the data and you can plot this relational plot yourself. Let me give this to you as an assignment. Can you do this assignment, all of you? Say a yes if you are confident that given any data set you can use the SNS.rel plot and identify the relationship between time, any two numerical columns. Okay, time point versus signal with respect to the event, the region, as well as subject, the way we added hue, style and size. Can you do it on your own? Can I give this to you as an assignment? Okay, please reply in the chat. Okay, so we'll move on to the next plot, that is the categorical plot. Okay, okay, so these are relational plots that I have been, that we are visualizing. You can do all these extra. Okay, you can try it yourself using the documentation, and so let's go ahead. Okay, now let's do using SNS. If you have to do a scatter plot, how would you do? It's the same. Okay, so you just give a scatter plot and you can view same thing. Somebody even asked me, okay, initially, okay, what is the difference between a rel plot as well as a scatter plot? It's just the same, but it's just that you are plotting the same thing. Okay, but you can add a lot more extra here. It's just the relationship. Okay, and now that was nothing but scatter plot. Okay, you can make a note of it. So SNS dot scatter plot is also specifically if you call it a scatter plot. Okay, SNS dot scatter plot. Okay, now let's move on. If it is a line plot, okay, so let me see. regarding scatter plot. Okay, using iris dataset. Okay, we have loaded this iris dataset, the one which we saw yesterday. Okay, you have loaded this iris dataset. Okay, and we are using it to plot the scatter plot and rel plot. Okay, here almost all the four columns, all the four independent features are numerical columns, so you can choose it and you can plot the uh, scatter plot or rel plot. Okay, if I even if I give a rel plot, it will be the same. Okay, okay, it's the same thing. Okay, petal length and sepal width. Okay, so it's the same thing, it's just zoomed out. Okay, you can try it yourself. Just load the data set iris equal to sns dot load underscore data set iris data set. This is a data set that we saw yesterday. Okay, you can explore and you can choose a rel plot. Rel plot scatter plot is over. Okay, and we will move on to the next one, that is categorical data plotting. Data plotting. Okay, so in categorical data plotting, again these are the difference. So whenever you have a categorical variable, I hope I told you. Okay, so whenever you have a particular column, okay, of numbers, it's a numerical column. If you have categories like age, I mean sorry, like sex, male, female, and then gender, I mean gender, or you have these sizes like medium, small, large, these are all categories. So whenever you have any particular and species of iris flower that you saw, serosa, okay, all that, those are categories. So such features are called categorical features. And for categorical features, if you have to plot, you have specific a sets of, you cannot use a relational plot or you cannot use a line plot for categorical plot. So you have to know that if you're given a data set, you have to visualize the data set, you have to identify which columns are numerical columns, which columns are categorical columns. So this is one of the thing that you do when you are visualizing or exploring on data set. Okay, when you are exploring a data set, you have to identify which are the columns that come under numerical columns or numerical features, and which are those columns which you can put under this, which are actually categorical features. Okay, this is something which you have to understand if you are going to, if you want to learn all about data science and machine learning and all that, you should know these things. Okay, difference between a numerical feature as well as a categorical feature. So till now, whatever we saw, the scatter plot, line plot, okay, all these, okay, are mainly for what, numerical plots. So for categorical plots, let's load in the, you've already done it, we have already loaded the tips data set. Okay, so we can just see. Okay, you can add this sns dot cat plot. Cat nothing but, cat plot is nothing but, it's a categorical plot between what, you have these categorical variable. Okay, day is a categorical variable. We saw Saturday, Sunday, Thursday and Friday were only the 4 days that were present in that data set. So the day is nothing but a categorical feature. Okay, and y is nothing but, so with respect to a categorical variable, how is the total bill amount varying, and with the data, this is the name of that data frame. Okay, data set that we have loaded as a, so we have saved it as tips. So that's the, so you can just view. Okay, so these are the days: Thursday, Friday, Saturday and Sunday. So on which of the days where the, what where their maximum number of, people and number of records were more, and what is the highest amount. Okay, and how is the variation each day. So you can analyze that. Okay, so I hope you can see this, it's zoomed out. So you can all plot it, cat plot, categorical plot, just plot it. Okay, with respect to the Okay, one category and one numerical variable. So X is nothing but day is a categorical column with respect to the total bill. How is the we can all plot it and tell me if you can see this, if you can do it. Okay, all of you please plot this categorical plot and just type it if you have done it. Please say done. Okay, done. Isha Bansal done. Pooja got it. Okay, very good. Are you finding it easy? Are you finding the session easy? All right. So many people, few of them have done it. Okay, done. Can you elaborate it once again? This is Harshit. Okay, you can go through the recording once again. All right. Like why we use it and all, in short. It's just to understand the data. Okay, based on how what type of data it is and how what type of analysis are you going to do. So it's just understanding the data. Nikita, please go a bit slow. I'm already going slow. I think one person even typed slow, and it's slow. Yes, ma'am, it was easy. Superb. So great that you're finding it easy. Okay, there's absolutely nothing to remember. It's just that you do it and you get the plot. That's all. That's all it matters. Okay, and you just visually just see the plot and just see what you can understand out of it. It's as simple as that. Okay, just look at the data set, look at the plot. Okay, first thing that you have to do is don't just blindly load a data set which you don't I mean which for I mean you should have an idea about the data set itself, okay, before plotting it. So you should just explore on the data the way I told you. Okay, view the columns, view the unique values, categorize it into what type of a column it is, if it's a numerical column or if it's a categorical column. All right. Yes, ma'am, it's easy. Okay. Okay. So somebody is asking me to show the. Okay. So if you see here, okay, uh, you can give this. Okay, cat plot. Just type SNS cat plot and the entire documentation for cat plot opens here. Okay, these are the scatter plots. Okay, strip plot, swarm plot, box plot, violin plot. So these are the so if it, when it comes to categorical, see scatter plots, it's there are two things. Okay, strip plot, swarm plot. These are the two types of plot. Okay, and if when you come to the estimate, okay, point estimates, categorical estimate plots, it's just to estimate each categorical value. Okay, you can use these. So so category, these are box plot. Okay, these are purely categorical distribution plots. So it will just show you the distribution, so you can just go through these documentations. Okay, wherein they have mentioned each and every parameter. Okay, so x, y and hue are the names of variables that are stored in the data. So x, as I gave you, okay, we already did it. X, we gave a particular column name to that. Y also a column name, and hue was another group. Okay, we added another column name. And data is nothing but data frame name. Okay, so these are the estimators, that additional these are the values that you can give within that cat plot parenthesis. These are different. If you want to share your x-axis and y-axis, you can give it as true. Okay, so these are, and by default also, which are the values that will be there by default are also mentioned here. Okay, So you can do all of it. Okay, and below that you are even given examples also. So it's so very simple. So here they have loaded, see, you can see this. Okay, they have loaded a data set called SNS load data set exercise. Okay, so these SNS, it's a, I told you. Okay, this is one of the data set, and they have done a cat plot between what, time, as well as what, pulse. Okay, so here we can do this. Okay, you can just copy it, and you can do here. Let's just see it how it is. Okay. Okay. Okay, so let me view the. Okay, so I have loaded the. So it's like unnamed ID, the diet, the pulse, the time. Okay, and what kind, the exercise data set. So let me type exercise dot. Okay, then this. Let's plot this thing. Okay. SNS dot categorical plot. So time is a categorical plot. Okay, versus this Y pulse. Okay, and hue is kind. Data is exercise. Let's plot it and see. Okay, so you have got it. The same plot. Okay, so there are, these are the categories. Okay, the time. Okay, it's just 1 minute, 15 minute, and a 30-minute exercise. It looks like, that these are the three, only within these duration, the pulses were recorded on exercising, in any of any kind, whether it was rest or walking or running. Only between these three intervals they had taken the a value of pulses. So what you can see is, what do you understand here? So when a person runs only for a minute, okay, this green stands for running, these red spots stand for walking, and the blue is rest. Okay, at rest. So what is the pulse of a person, pulse rate of a person? When a person is at rest, obviously it's the same thing. Okay, whether the person is resting for a minute, or whether the person is taking a rest for 15 minutes, or whether the person is taking rest for 30 minutes, the if you what you can see is the pulse rate are almost the same. But when you see the person is walking, okay, for a minute and for 15 minutes, it's slightly increasing. Okay, when a person is running for 30 minutes, you can see how the pulse rate is increasing. See, running for 15 minutes, you can see slowly, okay, when the person is running, how the pulse rate is increasing. Okay, so these are the kinds of analysis that you can do. Okay, so I hope you are getting an idea about how we can understand from the plot. Okay, the way we can understand the data ourselves from visually plotting. Now imagine you not able to plot. Okay, and you're just seeing this data. Okay, just looking at this data. Okay, how will you, what do you think you will, how can you understand this? See, I, without visualizing the data, you're just taking a look at this column. Okay, can you understand anything? Is it easy to understand anything? They've just given the diet, okay, the pulse. Okay, you can't get a clear picture about an entire the relation between the different variables. Okay, between pulse and time, between pulse, time, and kind. Okay, you can't get a good relation. So that it's for that reason that we are learning how to. We are just seeing how to plot it. Okay, so that is the ultimate aim. I hope you understood. Okay, so let's see, if have you all done it? Have you all tried it for exercise as well? Have you all plotted for exercise also? Exercise data set also? Let's move on. Okay. To this is the same thing. Okay. So this is a cat plot again, the same categorical variable, but here it is nothing but, see, you're given swarm. What kind of plot you want? Okay, that is nothing but, it's called okay. So here in SNS cat plot itself, okay, in the documentation you can see this. Okay, okay, so here these are the different kinds. Okay, see, these are the different kinds of plot that you can give. This is the same plot. Okay, here you can give in the documentation. Okay, they have given, see, the kind equal to swarm, kind equal to strip. Okay, these are, so this kind parameter is nothing but it selects the underlying access level function to use. Okay, so what is this access level function? It shows the relationship between one numerical and one categorical variable in different ways. It's just a visual representation. Okay, so this is a swarm plot. Okay, and this is a strip plot. So that's what you have done it here. So so here in swarm plot what happens is, so rather than, it just aligns everything. Okay, so all the points are kind of compressed. Okay, compressed, and you can view it here. It's a more clear visualization here. Okay, so have you all done it? Have you all completed? Please let me know if you've understood rel plot and cat plot. Have you all understood rel plot and cat plot? Okay, so in Seaborn, these are the different types of plots that you can do. Okay, so if I give, let's see what happens if we give it as strip. Okay, so it's a strip plot. So these are categories within the cat plot. Okay, so this is the strip plot. So it's like a strip, see, individual strip. Yes, ma'am, understood. Great, superb. Sai Charan, Vivek, Rahul. Okay, any data set. So right now we are using which one? Tips data set. Neil Sur, can someone please share the documentation? SNS. Just go to Google and type Seaborn documentation and you will get it. Do not worry about the assignments. Okay, you can just try hands on. Okay, don't worry about the assignments. I will be giving you, and you already have a link to regarding the assignment. You don't have to worry about it. Okay. Yes, for fMRI data set that was given as an assignment to plot the, okay, relational plot. Can be all, yeah, yes, Neil. All this can be done in Google Colab. So in order to make you familiar with both the platforms, okay, in Google Colab as well as Jupyter Notebook, that was the reason that I'm swapping between the two. So yesterday, day one session was completely on Jupyter Notebook. Day two was using only Colab, so you can use anything. Okay, let's move on. Okay, let's move on to the other plots here. Okay, so this is Okay, here let's move on to the next plot, which is very important. That is called as a box plot. Okay, so in this particular tips data set, okay, so you can give the kind as box. Okay, box plot. So what do you, in general, I think it will take you some time to understand box plot, because box plot also gives you an outlier. Okay, it's nothing but it'll so you have these boxes, okay, that represent how it is varying on a, upper quartile and lower quartile. See each of the line here. Can you see my cursor moving, all of you? So this is the 0, 25, the see, if you see, can see my screen here. Okay, see my cursor moving. Can you see my cursor here? All of you, please reply. Can you see my cursor here? I think my I have got a live screen. So this one, okay, just shows you how the data is distributed, all right, and how it is varying. Okay, so here this is the 0th value, this is the 100th value, this is the 25th. So majority of the data, this is the 50th percentile, 25th percentile, 75th percentile, and this is the 100th one. Okay, this is so 0, 25, 50, 75, and 100. Is that clear? So these are, this type of a graph is basically used to show you the kind of the distribution, what is the central value, okay, and how is it varying. Are there any out, see the, you can see certain data points outside the, you know upper quartile and lower. So this is called a box whisker plot. Okay, box and whisker plot. Let's so you can google it, box and whisker plot. Okay, so if you go to images, okay, so this is the this is better to explain. Okay, see, so here this is the box. Okay, this is horizontal, but you had seen it. Okay, can you see the screen? So here, this is the box plot that I was talking to you. So this is the minimum value of that particular column, all right? And this is the lower quarter. So this is called, so this is the 25th. This is the medium value. Median is the middle value. Okay, this is the 75th percentile, and this is the maximum. So the entire thing is called a, this, the in between is a box and a whisker plot. Okay, so it shows you a five summary of the entire data: minimum, lower quartile, upper quartile, medium value, and the maximum value. Hope you've understood. Okay, so suppose if I have to make you understand, okay, so there is so this particular value, okay, q3. Okay, so here let me see if it is there here. Mm, okay, so here you are not given. Okay, so here see, let's move on here. Okay, the first, see here, we'll discuss about box plot later. All you have to remember is, so it just gives you the distribution. Okay, it's a totally entirely, it's it'll take time if I have to explain it to you regarding the box plot. All you have to remember is, see, these are nothing but it just shows you the range of values that are present. Okay, so between 25th percentile as well as, so this is called, this box is called as interquartile range. All right, interquartile range. Okay, so here this bottom value of the box is nothing but q1, middle one q2, and the last one is q3. Okay, so q3 minus q1 is nothing but, this is called an IQR, interquartile range. Okay, so this is nothing but you can use this in order to find out what percentage of the data lies outside and okay, below the lower limit and above the upper limit. Okay, so here these points that you see above the 100th percentile, above the upper line, these are called as outliers. Okay, these are called as outliers in our data. Okay, outliers are nothing but very far off values compared to the entire data set, the range of the data set. Compared to that, what these are the values that are lying outside, so these are called as outliers. Okay. Okay, so for box plot, how do you plot it? So you can just using this seaborn and cat plot, you can just give the day column is the categorical column, y is the numerical column. You can give kind equal to box, okay, because you need a box plot. Okay, and hue is nothing but it's optional. You can add a third variable, okay, also third variable, which also here is a categorical variable. Okay, have you all understood? Have you all understood? Come on, please reply. It's just a one liner. Okay. So have you all understood? Okay, so moving on to the same thing. Okay, this is another, the same thing. Okay, you just added additional columns to it. Okay, so okay, so sex equal to male and female. Okay, here what is happening is, see, they are lying separately, okay, in this graph. So for Thursday you have two box plots, for Friday you have two box plots for each of the sex. Okay, for male and female, if you have to merge it into one, that's what we have done here. Okay, here so here what you have to do is you have to just do dot equal to false. Okay. Okay, dodge equal to false means here they are like overlapping one box plot over the other. All right, so it is all the representation, it's how you want to visualize it. If you want to visualize it separately, okay, so it's all optional. Okay, so this is another I hope, did you understand this feature between the two box plots, visualizing it? This is the basic thing that you have to know. Okay, did you all understand? Yes. Yeah, and people are asking how to make the graph horizontal. Just give orientation equal to horizontal. Yeah, Rahul Anand Raj is asking what's the dot above every box plot. So that is called an outlier. Okay, it's called an outlier. Okay, you can just see here. You go to Google and see outlier has nothing but this far off values. Okay, outliers. Define definition. So outlier is nothing but anything which is in data science. Okay, meaning of outlier in data science. So see, what are outliers? Okay, they are data records that differ dramatically from all the other values. Okay, so it's a value which is not normal. Okay, which is an anomaly or it's not normal. Okay, see, suppose you have let me explain it to you, you will understand what it is. Okay, I you have a this housing, suppose what here itself. Okay, you're plotting this housing data set, for example, for number of bedrooms versus the total price of the house, for example. Okay, you have this in order for a person who asked me regarding that outlier, please listen. Okay, outlier is nothing but, you suppose you are giving a housing data set. Okay, wherein the price of the house, the number of rooms in a house, the bedrooms in a house, the size of the house, there are different columns of this kind, and or the area of the house. All these they determine the price of the house, for example. Okay, and you are plotting based on the number of rooms, for example. In case when you're plotting a box plot, okay, or if you see there is a value which says the number of bedrooms is 33, okay, it's an outlier. So on the whole, all the number of rooms or number of bedrooms will be lesser than 8 or 9 or 10, okay. It will not be so high, so that is an outlier. So when you take an entire column on the whole, and when you're plotting the distribution, if you see a couple of values which are far off the range, okay, normal range, those are called as outliers. Did you understand? Okay. Yes. Okay, so we'll move on to the next one now. So here also we have, okay, so this is also a category, this is a, okay, box plot, okay, box and kind of a plot. Okay, here also we have loaded another data set, okay, called diamonds. So using the same way, now I think you are almost very much familiar with this, how do you load the data set? Okay. Yes, ma'am, understood. Superb, great, great doing. So here we have loaded another data set, okay, wherein you have this SNS. Okay, this is a diamond data set. Okay, there are number of features which are numerical here. Okay, it's like the depth, the table, okay, price, X, Y, Z. Okay, then we are plotting a categorical plot, okay, between the, okay, color as well as color, which is a categorical variable, as you can see. Okay, and the price. Okay, and you're plotting the plot, okay, kind as box in, as I told you here earlier. Okay, SMS cat plot. Go to the documentation. Here you had seen this, okay, categorical distribution plot. Okay, so box and plot. Okay, box and plot is nothing but, it's nothing but for a larger data set. Okay, so it is enhanced box plot. Okay, enhanced blocks plot is a box and plot. So it shows a large number of quantiles that are defined as letter values. It's very similar to a box plot, but just that it has additional representations, non-parametric representations of the entire data. Okay, so here even have a paper to read here. Okay, on letter value plot. Letter value plot was the original name, and this is the, it has been renamed as box and plot. Okay, so it will just give you, let's see what it is. Okay, so let's go back here, and you can just sort the values, okay, as color. Okay, so you can give this data equal to what, diamonds dot sort of color. Okay, okay, so the entire all the uh, okay, will be plotted with respect to the, okay, sort color. Okay, and you can see this diamonds dot head. All right. Okay, so it's sorting it with respect to the colors. Okay, so all the colors. All right, and we can see what the box and plot looks like. Okay, so these are the, so it's the same box plot, but then you have the width, okay, varying. Okay, the range of values, okay, between each. So this is also an enhanced box plot. Okay, so okay, have you all plotted this? Please, you can do it. You have got these labels here. You can just type in, and you can check it. Are you getting the plot, all of you? Are you all getting the plot? Okay, so have you all understood this? So this is nothing but, I told you, right, in box plot, as I told you, see, you have these five values, okay, 5 point summary, okay, five number summary of box plot. You have a minimum value number one, okay, number two is the Q1, lower quartile is nothing but 25th percentile. The third thing is median, 50th percentile. The fourth one is upper quartile, that is 75th percentile. And the fifth one is max, okay, 100th percentile. So this is nothing but a box plot. But what is the difference between a box plot and a box and plot? In box and plot, what you happen is you can see the distribution from here, from the minimum to the maximum value, the shape of the distribution. How is it from head to tail? Okay, from minimum. So see, that's what it is. See, what is the shape of the distribution? You see, it's varying. See at the lower, you can see the starting of it. Okay, so it is varying, right, between how the upper value is and how so this is the box, and how is it varying between the 75th percentile as well as the 100th percentile. So that variation is what is seen. Okay, so you can plot, so that's the difference, nothing much. Okay, and it's the same thing here. Dodge is equal to false. Okay, so here again, okay, so these will be overlapped, and here you have got the days column versus the total bill. Okay, this is again a box and plot. In box and plot, what happens is, as I told you, every quartile, it will show you the shape of the data. The shape of the data distribution is seen. Okay, in every quartile between minimum and 0 and 25, 25 and 50. Okay, 50 to 75. So every quartile it's seen. All right, did you all understand box and plot? Exactly. So, yes, I'm seeing the chat. I hope you have understood this. Okay, we'll talk about the next violin plot tomorrow. So in violin plot also it's the same thing. Okay, violin plot, so it's the same thing. See, you are in instead of swarm, strip, a box in, you have to just give violin, and you can view it. Okay, you can do it and see for one categorical versus one numerical plot. You can give a third variable also as hue, and you can give the data. Okay, data here is tip, so it looks like a, this is what is called a violin plot. Okay, again it will show you the shape of the distribution of a categorical this is a categorical, so y is nothing but day. Okay, in y axis we have given day, in x axis we have given a numerical column. Okay, numerical column is labeled, so x versus y, so you can even reverse it, okay, the way you want. Okay, so this is the same thing, so you can just play around with the data. All right, and okay, okay, this is the count plot. Okay, this we can continue the rest tomorrow. Have you got any doubts? Did you enjoy the session today? Did you enjoy the session today? So let's just finish it with this. Okay, violin plot. Okay, just let's finish it with a violin plot for today, and we'll continue the rest tomorrow. Okay, so this is all about Seaborn documentation. If you have any doubts, you can just Google search Seaborn documentation. You don't have to remember the code. You just can download the data set and you can load it. Okay, either using pandas, and then you can start using your Seaborn for visualization. Did you all enjoy the session today? Did you all understand? Did you all plot it? That is the main thing. Okay, so I'm looking at the chat. I have a minute more for the session to end, so you can all type in your comments, or your comments regarding today's class on Seaborn. Okay, I'll give you the assignment. Okay, I'll be uploading the assignment for today. Okay, so it's that fMRI data set. You can load that data set and you can do all these plots on it. Okay. Okay. All right. So that's all for today. I'll see you all tomorrow. You can practice this visualization. You can go through the Seaborn documentation. All right. So let's end it up here. All of you take care. Enjoy. Have a great day. Thank you so much for attending. Thank you so much. So I'll be uploading the assignment. Okay. Don't have to worry about it. You can just go through these. You just have to be able to load the data set and visually see it. Okay, just plot it and try it at your home, try it anywhere. Okay, thank you.